All right, number 4, the infamous potato problem. All right, a bunch of information in this problem. The key element here is the derivative of the temperature as a function of t, or with respect to t, is this formula right here. Write an equation for the line tangent to the graph of h at t equals 0. I need to know a value of h of 0, and I need to know the derivative of h at 0. So the value given is 91. The derivative I'm going to have to get from this formula. So it's going to be negative 1/4 times the h value, which is 91, minus 27. That ends up being negative 1/4 times 64, which is negative 16. So that's my point, that's my slope, and my formula is going to be h minus 91 equals negative 16 times t minus 0. And this might be a good one to put in slope-intercept form. So negative 16t plus 91. And then it asks us to use that equation to approximate the internal temperature when t equals 3. So h of 3 is just going to be negative 16 times 3 plus 91. That's going to be negative 48 plus 91, and that's going to be 43 degrees Celsius. All right, part B asks us to find d squared h dt squared. That's the second derivative of h. Let's do that to start. So I'll go up to the derivative expression, take the derivative of that. So it's going to be negative 1/4 times the derivative of h minus the derivative of 27, which is 0. So I just get negative 1/4 dh dt. Since I have a formula for dh dt, I'm going to use that formula and replace dh dt with what dh dt equals. And that's going to give us a final 1/16 times h minus 27 formula for the second derivative. All right, and the question says, use that second derivative to determine whether the answer we got in part A is an overestimate or an underestimate of the internal temperature. So at that time, or around that time, the temperature was 91. It actually says up here that the temperature is greater than 27, always. So that means that this quantity is going to be positive always, which means that the graph of h is concave up always. And any tangent line at any point, we just figured out one at t equals 3, is going to lie below. So since the second derivative is positive, the tangent line estimate from part A is an underestimate. All right, part C gives us a new formula. It's another formula that's attempting to model or give us the rate at which this potato is changing temperatures. It gives us an initial temperature of 91 again, and this time it asks us to come up with a formula. So while before I didn't have to find a formula for h, now I'm actually finding a formula for g. So this is a separation of variables problem. I want to move all my g's to the other side, so I'm going to get g minus 27 to the negative 2/3 when I divide by this. And this negative sign I can kind of just leave, so I'm going to do negative dt. And then I'm going to integrate, this should be dg, sorry. I'm going to integrate both sides of that equation. The antiderivative of g minus 27 to the negative 2/3 is g minus 27 to the positive 1/3 with a 3 out in front. And then the antiderivative of negative 1 with respect to t is just going to be negative t. Don't forget your plus c here. And I want to figure out a formula here for g. So I'm going to divide everything by 3. And that gives me negative t over 3. C divided by 3 I can kind of keep as a constant, so that's still just c. I want to cube both sides of this equation, and so I get c minus t over 3 cubed. And then if I add 27, I get c minus t over 3 cubed plus 27. I have an initial condition up here of 91, so g of 0 equals 91, and that's going to be equal to some number c minus 0 over 3 cubed plus 27. When I subtract here, I'm going to get 64 equals c cubed, and so c is going to be 4. So my final formula for g at any time t is going to be 27 plus 4 minus t over 3 cubed. And it finally asks us to find the temperature at 3 based on our equation. 27 plus 4 minus 1 cubed, that's going to be 27 plus 27, which is 54 degrees Celsius.